Hello friends, I hope you are well. Today, in the continuation of the topics related to reading the map on the phone, we are going to examine the battery connector paths from the iPhone 4 to the iPhone 12. We will work in two sessions. From the iPhone 12 onwards, we will talk about them in detail in the next tutorial. Note that the battery connector in the iPhone consists of a number of different bases and forms. There are also different paths, including the SPA path, the SCA path, the SWI path, the NTC path, and the paths connecting the connector to the XC PU, as well as the positive and negative paths of thermal data transfer. On the battery connectors of iPhones, there are different base forms. Please watch the clip until the end. We will explain everything in detail. Be sure to subscribe, comment, and like us so that we can provide you with better tutorials on the channel. Let's continue with all the topics related to reading the battery connector map in iPhone Series 4 to Series. Let's examine 12 in full. Friends, we chose the iPhone 4 for the first model. As you can see, we have the iPhone 4 battery connector. The first pin is the VCC pin, the battery voltage pin. The voltage pin goes to the board. The second pin is the gas gauge connector, which does the same thing as the BC and is used to measure the battery level. The third pin that we want to talk about is the NTC pin, which as you can see is the NTC pin, which detects the battery temperature. As you can see, there are two paths that are marked in this area. And finally, we have the GND pin, which is the negative pin. The next map we want to talk about is the iPhone 4S. If I were to go ahead with the map, as you can see, the 9J connector, as you can see, we have the VCC pin, the voltage pin, the power pin, which has the battery on it. In the meetings, we explain what it is for. We have the battery SW, which has the same function as the BC, and finally, we have the battery NTC, which has the gas gauge pin in this phone turned into a SWI. If I were to follow this pin, see where this pin went. You can see in the map that it has entered the XC PU, which has the battery information SWI and sends it directly to the CPU. And again, you see the gas gauge mode here, which is on it, and the gas gauge pin has turned into a SWI pin. and again, we have another path that comes under the CPU, and from another path, the voltage is 9.5, so that path we have this amount of voltage with 9.5 volts. The next model we will explain about the iPhone 5 because we are going to explain all the iPhone models, and now we will come to the iPhone 5. Here we have the iPhone 5. We have the iPhone 5 battery connector, which is with an iPhone 6J connector. The first pin is the BAT VCC pin, which has a number of paths, and through the point test you can easily do the related tests. The second pin is the SWI battery pin connector. As you can see, this pin and both pins do this. It is the SWI pin which we explained earlier. The next pin is the NTC battery pin. Let's follow this path. In the iPhone 5, it is as a battery path. Here you see the battery connector. Friends, it is exactly the same two pins here that we have the BAT pin on one side and the BAT pin on the other side. We have the SWI pin on the left side, the SWI pin on the right side, and the NTC pin on the right side. We can see the NTC pin on the left side. Let's go into the next model. Let's check the iPhone 5S. Let's see that. Now we have the 5S. I'm going to bring the battery connector path. Here the iPhone 6J connector is different from the iPhone 5, which is a 4-pin, 4-way connector, 3X, and 3-pin, 3-way connector. Again, we have the battery connector and we have two TP test points that we can do the tests on. The next API battery, SWI base that goes directly into the CPU, and as you can see, this path is completely under the CPU. If I were to follow the path, you'll see that there is no path under the CPU here, but we have two pieces that are directly under the CPU path. That are directly under the CPU path. Let's check the next model, the iPhone 6. I'll bring you the tutorial to talk about it. Inside the iPhone 6, our connector has become a 4-pin battery connector. The first pin is the BAT VCC pin, which you can see is 2 pins. An important point is that you can see for yourself that many parts of the board have paths. This is the latest model of the iPhone, which has different pins and paths, and many parts of the battery have gone. The second path, which you can see, is the 4-pin, which was originally the 2 upper pins and the 2 lower pins, has become the SWI. You can see that it is completely located here. If you look carefully, the open path is not under the CPU, and on the other side, there are two pieces under it. As you can see, two pieces have been inserted into the charging IC. The IC is the charging IC. As you can see, the Tigris charger is the charger. From the iPhone 6 onwards, the suite does not go under the CPU and is placed directly under the charging IC. This is a change that has completely occurred. Let's check the next item, my friends. Now, if I bring a battery connector, as you can see, we got a branch path from the PP-BAT VCC path. It is the battery sensor, which is also known as the battery thermal sensor. This path is the fourth path that is inside all batteries. Friends, when we entered the 6S, the connector has become 3-pin again. The first pin is, as usual, PP-BAT VCC, the battery voltage pin. It is completely clear that we have two test points under the battery connector, which you can see. The next path we want to talk about is Tigris battery. Tigris means the charging IC. As you can see, it is in Tigris mode and the SWI is directly connected to the charging IC again. So the three pins are the positive pin under the charging IC and the negative pin is the negative pin. There is the next iPhone 7 model, where you can see that the positive BAT VCC pin is the SWI pin of the battery connector. As you can see, it comes this way, and if we follow its path, you can see that it is inserted in two pieces. Now, the interesting thing I talked about the iPhone 7 is that instead of going directly into the charging IC, it goes into a Tigris 2, on one side of which is the SWI path, and on the other side is the 1/8 SDRAM path, and a path that is direct CPU power. That is, although we have Tigris, this means that it goes directly under the charging IC. This does not actually happen, and here we have the charging IC, GRIS charger, which is the charging IC. But actually, this BC path is the same SWI that does not enter the IC at all, and as you can see, it is placed under a Tigris 2, which has on one side, the 1/8 SDRAM path, which is powered by 1/8 SDRAM, and on the other side, the 1/8 voltage under the gauge path. The charging IC goes inside the connector itself, meaning that practically here, we have a pin that is 1/8 and we have a pin that is the charging IC and we have a pin that is the battery connector series. This path in the iPhone 7 is towards the IC6X bias. Let's check the X in the iPhone 8. The iPhone 8 has undergone a complete transformation, and there are no cases like the iPhone 7 like the iPhone 8. As you can see, our connector has not changed at all. The appearance of the connector has changed. There is a positive pin and two test points on top and its paths, and the cable is directly under the charging IC like the rest of the phones. Let's see the other paths. We have the cup path and the SCL path of the connector. As you can see, this path is checked with Tigris 2, and this path is also checked with this path. We have two important points here. In discussing this connector and the paths that you see, we have an SCL path that is clear and an SPA path. Friends, these pins go directly into the CPU, and this is because from the iPhone 8 onwards, we have the battery serial number as a battery error after replacing it. As you can see, here is the connector path. Click on one of the Tigris 2 pins. As you can see, it has no path, and it's entered through a resistor, and if I turn this resistor back, it goes into the CPU data path, which is somewhere else. Now if I click another Tigris 2, it has one pin in the path and another pin in the SDA path, which is now entered under the CPU. If we want to check the next pin, this SDRAM is a pin that has a voltage connection of 1/8, which supplies power to these two SRAM numbers. We see that it is entered in different parts of the board and the power is CPU power, meaning that the Tigris TOS take their power from the CPU in the CPU world path and its data enters the CPU directly. This is what happens from iPhone 7 and iPhone 8. And we have the data paths and the command path of the CPU itself. We have the SCL and SDA paths, which are completely the command paths of the CPU. Batteries are almost made in the same form from this model onwards. Let me bring you the iPhone XC, it is almost the same, and there have been no significant changes. We have the battery connector, which as you can see is exactly the same again, BAT VCC. The SDA pin in Tigris 2 and the SCL pin in Tigris 2 are exactly similar to the iPhone 8. We open the iPhone 11, friends, we have the iPhone 11. As you can see, J7000, we have the VCC path and the BAT VCC, which is also the yanked C phrase, which enters the charging IC and is charged directly under the IC. There is also a path between the floors. We have the SCL path, which is exactly the same as the previous models. Friends, the second path is SCL, which is in two pieces that are directly under the CPU, namely Tigris 2, but it is the same path, without the open switch. The S3 path that we have has a number of pieces that, if I take the resistor, are directly under the CPU. The only thing that has happened after the X to the iPhone 11 is the removal of Tigris 2, which separated the pins and took them with a voltage of 1 to 8 and acted as a switch. Only the Tigris TOS were removed and the paths are placed directly under the CPU. Let's bring the iPhone 12 map and check it out, friends. The important point is that the connector is exactly the same as the previous ones. We have the same form. The large pin is the VCC yanked C pin, it has gone under the charging IC, and the path is I2C2 SMCS. Now there is a point. The path is the same, but the data in some iPhone 11, iPhone X, and iPhone 8 was directly under the CPU, but if you look here, we have no path under the CPU, and the path is directly under the charging IC. Since this path is the CPU command path, the CPU command is executed directly on the charging IC. It goes from the charging IC to the connector. As you can see, there are two complete paths here, I2C2 SMCS.1 underbar 8 and SCL1 underbar 8. There is a difference. Again, the battery data is displayed directly under the charging IC, or yanked C charger, or whatever name is known. The difference is that it is created inside the iPhone 12 and we brought the iPhone 12 Pro Max, which we can also test on the other two models, from the map and do it and find the root.